Hi everyone, let's take a look at another textbook question on page 91, number 12. We have to determine the equation of a function f of x equals ax squared plus bx plus c if the graph passes through the point 219 and it has a horizontal tangent at -1, -8. Let's write the information down. So it seems that we're given some function in quadratic form, standard quadratic form, ax squared plus bx plus c. We are missing three coefficients here, a, b, and c. But we're given some information, so we are given that this function will pass through the point 219. So what does that mean? It means that the coordinates, or the x value of 2 and y value of 19, must satisfy the equation. So we are going to quickly apply this to the equation. So f of x will be equal to 19, so that's a value of y, and it would equal a, which we don't know, multiplied by x squared, x is 2, so 2 squared, and then plus b, which again we don't know, x is 2, so we'll substitute that, and then plus c. Let's simplify and see what this looks like. We have 4a, and then we have 2b, and then we have 1c, all together equal to 19. So this will actually give us a relationship between the coefficients a, b, and c, but in no way we can figure out what a and b and c are at this point. So we need more relationships between a, b, and c in order to solve for them. And remember that whenever we have three unknowns in an equation, we're going to need three different equations that relate them together. If we have two unknowns, we need two equations, and so on. So if we read the problem a little bit further, we see that we have another point here, -1, -8. This is, I'm telling you, a very special point. So here we have, at this point, we are drawing a horizontal tangent, and we are given the coordinates of it. So what that means is that the coordinates, or this point, is on the graph of the function. So the x and the y of this point will satisfy the equation of the function. So we'll make note of this. So -1, -8 must satisfy the equation, which means that for the function f of x, the value of y of -8 will be when x equals -1. So a times -1 to the power of 2 plus b times -1 and then plus c. Let's simplify. So we'll have -8 equals positive a, remember -1 squared is 1, minus b plus c. And this will be our second equation that relates a and b and c together. So let's give them a name actually. So we're going to call this equation a and this one equation b. And we're going to use this same point in here because to find the unknowns, because we know that at that point the tangent drawn on the graph will be horizontal. So what does that mean, that the tangent is horizontal? And you're probably thinking tangent horizontal means slope of the tangent must be equal to 0. So what else does the term slope of a tangent remind us of? Well, slope of the tangent is a derivative. So what that means is that the derivative f prime of x must be equal to 0 at x equals -1, y equals -8. So let's apply this to the equation of our function. So first we will need to find the derivative of this function. So f prime of x will be equal to a times derivative of x squared, which is 2 times x, plus b, derivative of x is 1, and then plus c, which is a constant and has a derivative of 0 because a constant never changes. So the derivative, or the speed of y values, is 0. So let's simplify this. We have f prime of x equals 2ax and then plus b. Now remember that we are told that the derivative at x equals -1 would be equal to 0. So what that means is that x -1 will give the derivative a value of 0. So we have in here 2a times negative 1 plus b equals 0. So the third equation that we create here is negative 2a plus b equals 0. And we're boxing this up as well, and we're gonna give it a name. This would be our equation C. So as you can see, we have three different equations that relate the coefficients A, B, and C together. And we're gonna use the three equations to find the missing coefficients. And as you can see in here, the last equation only has two coefficients. So what we're gonna do is we will try to express one of the coefficients in terms of the other. So it seems easier to express b in terms of a. And you can tell here that b is equal to positive 2a. And we're going to take this b value and substitute it in both equations a and b. So let's see what this is going to look like. So we have 19 equals 4a plus 2b plus c. That's equation A. And we have negative 8 equals a minus b plus c. So we will form a system of equations here. And we will bring the value of b, or the coefficient b, equal to 2a. So we'll replace the coefficient b, in other words, here and here. So let's see what we get. So we'll have 19 equals 4a plus 2 times, remember b is equal to 2a, and then plus c. And the second equation will be negative 8 equals a minus, instead of b we have 2a, and then plus c. So let's bring them together. Oops. It seems easier if I copy and paste this. All right, so here is our system. And as you can see, we have created a system of two equations with only two variables, a and c. Let's simplify each equation. First, we have 19 equals, we have 4a plus 4a, 8a, and then plus c. And here we have negative 8 equals a minus 2a, that's negative a, and then plus c. So we can solve the system by using either substitution or elimination. I find elimination a more practical way of solving a system, a linear system of linears. And as you can see, we have the term c, which has the same coefficient. And you know that when we use elimination and we want to eliminate terms that have the exact same coefficient, same sign, then we subtract the equations from one another. So that means that we have 19 subtract negative 8 equals 8a subtract negative a, and then c subtract c, which is basically nothing, and we don't really have to write it. We don't usually write it. So 19 minus negative 8 equals positive 27. 8a minus negative a, sorry, there is a negative here, so that would be 8a plus 1a, that's 9a, and then c minus c is 0. So we have the value of a equal to 27 over 9, or a equals 3. So once we find the value of a, we can easily figure out the value of either coefficient c if we wish. So we have two equations that relate a and c together, or we can find b by using the relationship b equals to a, which will make the value of b 2 times 3, or even better, b is 6. And now that we have a and b, we can use so many different equations. Actually, we have so many options to find c, so we can use either simplified form of the equations that relate a and c together, or we can use the equation b or equation a. It doesn't really matter. So just for the fun of it, I'm going to use the equation b, which is negative 8 equals a minus b plus c. So negative 8 equals 3 minus 6 plus c. Sorry, c here. And negative 8 plus positive 3 equals c, which will make the value of c equal to negative 5. And that would be the coefficient c. So the key actually information, and the information that we use slightly differently than before, is this point in here. So if we are given the point of tangency and the value of the slope of the tangent at that point, we are given actually two pieces of information. So we can use the derivative of the function, the value of the derivative at this point, and we can use this point into the equation of the function. And that's a new thing that this problem brings, and hopefully helps us understand and use it in other in other questions and in other problems. And thank you for learning with me as always, and bye for now. Enjoy the weekend.